For tonight's homework, this is lesson 3. Students worked on the following today in class, thinking about place value, commas, and the magnitudes and how the commas separate those. Students should have an understanding that the commas come starting at the ones place. They want to count out 3 digits to separate the hundreds from the thousands. So there should always be a comma between the thousands and the hundreds. There should always be a comma between the 100,000s and the millions, and then the millions and the billions. And students should use the strategy of using 3 digits starting at the ones place. So if we look at C, they should see the ones, tens, hundreds, and see that there's a comma separating hundreds and thousands. And then as the numbers grow larger, they'll separate the thousands from the millions. For problem number 2, the directions are to solve each expression. So what students should do is they should combine the 2 digits and then include the place value if they're the same, which in this case they all are. So they should include the digits and then they should write it. So here the expression, if we look at the second one, 800s plus 200s, we know that that's 10 hundreds, but that's not in standard form. How we'd write 10 hundreds, thinking about students in class have made an exchange. When you have 10 of anything, you can exchange it in for the next largest thing. So 10 hundreds is actually equal to 1,000. That's how it would look in standard form. So students should remember that anytime they have 10, they can exchange that in for the next largest thing. So for tens, the next largest thing would be hundreds. And for every 10, they're going to exchange in for 100. Here for thousands, for every 10 thousands, they can exchange that in for 1 10,000. Students should do that exchange so they can help see the number in what we call standard form. For problem 3, it asks students to represent the add-ins with place value discs on the chart and then show the composition of the larger unit from the 10 smaller units. So it's the same idea they did up here where every 10 units can be exchanged. So I'll show you how to do B. So they should make 14 10,000s. So that means they need to put disc. We've been doing dots, so they're welcome to do that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 12,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Students should have this understanding that 10 units can be exchanged. So if I think about these 10,000s right here, I know that they can become 100,000, leaving me with the 4 10,000s. I know that I can also exchange 10 of the thousands and move them over here, and that becomes 1 10,000. So now I'm going to make my discs a little bit bigger so that we can count. I've exchanged those. So I have 100,000. I have 1, 2, 3, 4, 5 10,000s. And then I have 2,000. No hundreds, no tens, and no ones. So I can see that for every 10, I can bundle them and make one of the next larger thing. So my number for combining those is 152,000. So the key here is to bundle 10 units and move them and exchange them into one of the next larger. Problem 4, students are going to now not exchange, but what they're going to do is they're going to show a multiplication problem. So what they would do first is they would start by drawing the disc for the value. So here, I'm going to actually go to problem B because I think it's a little more challenging, and then problem A should be easier. So the first one is 4 10,000s and 4,000. So I'm going to draw the disc in each of those places. And then I have 4 in the thousands place. When I multiply by 10, I'm not going to bundle, but I know that I'm going to move my items over to the next place. The place value system works by taking each value. If we make it 10 times bigger, it goes into the next place value. So I can follow the same strategy with my place value disc. I can say these 4,000s times the 10 are going to become worth 4 10,000s. And these 4 10,000s I started with times 10 will become worth 400,000s. Because every time I times 10, I increase the place value of the digits by 1 place. So here I have 400, 4 10,000s, no thousands, no hundreds, no tens. So my value becomes 440,000. So anytime students are multiplying by 10, the idea is that they understand that becomes a 1 place greater in value. Question 5. So this is where students again would read and solve the problem. Here we see that a large grocery store has an order of 2,000 apples. So I'm going to underline that known. A neighboring school receives an order of 20 boxes of apples with 100 apples each. Use dis or dis on the place value chart to compare the number of apples received by the school, the number of apples received by the grocery store. So I would again suggest what the problem does, which is a place value chart. It can look just like the one above it. Students can label it and then show the value of each disc. I'm just going to use initials here because the spot's a little small. So first they would show 2,000. So here's the thousands place. They would show 2. Then they received an order of 20 boxes of apples with 100 apples in each. So if they have 100 apples in each one, we can draw the hundreds, but we need to draw 20 boxes to represent each 100. So students would need to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The reason they have to do that is because it's 20 boxes with 100 apples. Students are going to have to bundle these up and exchange them. So once they do that, they can exchange them for 1,000 each, and then comparing that to what the grocery store received.